Okay, last objective here, using a sampling distribution of a statistic to evaluate a claim about a parameter. We have done these claim problems, right? These are the whole convincing evidence questions, right? So again, old news. Example 3, how long will we be doing homework? Ha ha ha. At the beginning of class, Mrs. Chavez shows her class a box filled with black and white beads. She claims that the proportion of black beads in the box is P equals 0.5, meaning there's half black and half white, right? Okay. To determine the number of homework exercises she will assign that evening, she invites the students to select an SRS of n equals 30 beads from the box. The number of black beads selected will be the number of homework exercises assigned. When the students select 19 black beads, p hat equals 19 out of 30, which is 0.63. The students groan and suggest that Mrs. Chavez included more than 50% black beads in the box. So again, what's the setup here? If we're picking 30 beads, the students expect to get 15 black beads because there's a 50% chance that it's black and white. 15 is half of 30, right? So they expect only 15 homework assignment or homework problems, but now they're going to get 19. Son of a gun. She must be lying to us. She wants us to do more homework. All teachers don't hate you. Get over it, okay? It's called statistics and probability. So to determine if a sample proportion of p hat equals 0.63 provides convincing evidence. There's those words, right? Convincing evidence that Mrs. Chavez cheated. The class simulated 100 SRSs of size n equals 30, assuming that she was telling the truth. That is, they sampled from a population with 50% black beads. For each sample, they recorded the sample proportion of black beads. The result of the simulations are shown. So this is the sampling distribution for the sample proportion of black beads. There we go. Okay. So again, a lot of stuff going on here. The most important number here in this entire problem is right there, your p hat value. Do not lose track of that p hat value. 0.63 is our value. Okay, so A, there is one dot on the graph at p hat equals 0.77. What does this dot represent? So where is 0.77? Oh, it's right here. So this is p hat equals 0.77. Well, what does that mean? Well, it means that in one sample of size 30, 77% of the beads were black. So I think this is a very, very base example, means like, elementary, but it's important because I think we forget what these dots mean. Each of these dots is a sample proportion of black beads out of 30 beads. Okay, so be aware of that. All right, and again, whenever we interpret things, we typically change our proportions into a percentage. Okay. All right, B, would it be unusual to get a sample proportion of 0.63 or higher in a sample size of 30 when P equals 0.5? So this word unusual also means rare. And remember what rare means? Rare means in this class less than 5%. How often do we get a proportion of 0.63 or higher? Is it less than 5% of the time? If it is, then it's unusual. If it's more than 5% of the time, then it's not unusual. So let's look at our dot plot. So again, if this is 0.77, I hope you can believe that these are broken into thirds. So this is 0.66. These dots right there are 0.63s. Those dots right there are 0.67s. So we want 0.63 or higher. Because again, if it's higher, that means they'd be doing more homework, and that would be more evidence claiming that Mrs. Chavez cheated. So how many dots are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 dots out of the 100 simulated. That is a percentage of 9%. Uh-oh, that's not less than 5%. That's greater than 5%. So we would say no. In 100 samples of size 30, 9 of them contained 63% or more black beads. You could say 9 of them had a sample proportion of 0.63 or more black beads or higher. You could just restate this, right? Okay, but they again change it to a percentage. So in 100 samples of size 30, make sure you include the sample size. 9 of them contained. That word is contained. Maybe I should write that better. Contained 63% or more black beads. And again, that means that 9% was greater than 5%. So it's not unusual. Okay, so now based on your answer to part B, is there convincing evidence that Mrs. Chevet lied about the contents of the box? When your percentage is more than 5%, you don't have convincing evidence. No, there is not convincing evidence that Mrs. Chevet, when I say this, I think I am Kevin O'Leary or Mr. Wonderful on Shark Tank, right? He always talks about his wine clubs. Chevet lied about the contents of the box. And that is because, again, 9% is greater than 5%. Now, I do have some people that like to change the wording. They like to say, instead of there not being convincing evidence that she lied, people like to say there is convincing evidence that she was being truthful. Again, don't change the wording. We'll get into it further, but this one sample provide convincing evidence that there was not, or did not provide convincing evidence. You might get another sample that does provide convincing evidence that she lied. So again, don't change the wording. Use the wording they give you. Okay. But again, to me, these are old news problems. All right. Okay, awesome. So do your best in this assignment. Section 6.1 is a little bit longer, but it's very important. 6.2 is very short, so you'll see that tomorrow.